All right, so remember, we're in topic 9, block 4 today. Our goals and objectives are to develop a probability model and use the model to find probabilities, find the probability of a simple event and its complement, represent sample spaces for events, make predictions based on results from experiments or theoretical probabilities, and to explain the likelihood of an event in terms of its probabilities. So to get started today, I have a bag right here. Not sure if y'all can see this or not, but I got a bag, and it has 12 identical size blocks inside of it. All right, I have blue cubes, green cubes, and yellow cubes, but I'm not going to tell you how many of each are inside of there. So what I want you to do is I want you to try to brainstorm predictions and ways that you could explore the number of each color in here without counting them. What could you do?
Like we could take guesses and make guesses. So
Yeah, we could guess. And what would allow us to make better guesses of what's actually in there? What could we do?
try.
Yeah, we could draw them out. So if I shake this up and I draw one out, I got a blue one. All right, I'm going to put it back. All right, I'm going to shake it up again. I got a yellow one. So far, we got a blue and a yellow. I'm going to shake it up again. We got a green. So we got blue, yellow, and green so far. Now we got another yellow. We got another yellow. We got a green. So far we got pulled three yellows, two green, and a blue. Got another green. A blue. So out of this amount that I've done, that I've drawn, what would you say has the most amount of one color in there? What are you thinking?
Yellow and blue.
Okay.
Yellow.
Okay. So what do you think we could do to be at a more exact figure? What would I have to do?
Do more trials.
Yeah, we'd have to do a lot of trials. And so, yesterday we found out that when we did more trials, it brought us closer to the what? It was like the key point in yesterday's lesson, in block 3. Whenever you perform more trials, what happens?
You get closer to the experimental probability.
Very close. The experimental probability gets closer to what?
Theoretical probability.
Yeah, good teamwork. Good job. All right. And that's what would happen here. All right. So, what I want us to do is I want us to look at this. It says, in this game, you will use an object at random. When you randomly select an object, you will choose it with no regard to order or preference. We're going to start with a container of blue, yellow, and green objects. We're going to close our eyes and randomly pick an object from the container. And we're going to predict the color we're going to pick. And it says we'll win if we you will win if you guess the correct color. So we're going to conduct an experiment of 20 trials and record the results and determine an experimental probability. So let me get this light on real quick and then we'll do that. All right, so let's take what we got. So we're going to take our bag and we're going to see what prediction we can make. So let's go with Chris. Chris, what color block do you think we're going to get out of this? Chris is taking too long. Deonti, what do you think? Just make a guess. You can only pick three colors. It's either going to be green, blue, or yellow. What do you think?
I'm thinking blue.
All right, she said blue. Was she right? Yeah, so you got a win. All right, so for the first one, we want to write blue down. So make sure you're taking a record. Emma, what are you thinking will be drawn? All right, she said yellow. So first one's blue. Is somebody writing that down? Make sure you write it down for us. All right, she said maybe yellow. I got a green. All right, so did she win?
No.
All right, so far we got a blue and a green. So we're gonna do it again. Haley, this one's yours. What are we gonna get?
Yellow.
All right, she said yellow. We got a green again. All right. So far, what do we got?
Blue.
All right, Isabella, I want you to pick.
Blue.
All right, she said blue. Let's see. Hey, so far, every time somebody says blue, they're getting it. All right. So we got two blue and two green. All right, our next person, let's see who we got. We got Miss Jemiah. What do you think we're going to get, Jemiah?
Green.
All right, she said green. We're going to see. She got it. All right. So what do we got so far?
Two blues and three green.
All right. Next, we got Mr. Joel Rogers. Joel, what color do you think we're going to get? Joel's taking a little while. Kaylee, what do you think?
I guess yellow.
All right. We hadn't had much luck on yellow. We're going to see what happens. You got it. All right. So she won. So far we got 3 people that have won, right? Or 4 people? All right. Laney, what color do you think?
Green.
Green. You're close. All right. Eli, what you thinking?
Blue.
All right, Eli says blue. Blue's got it. All right, so are we on 9 now or 10?
9.
All right. Layla, what color do you think we're going to pick?
Yellow.
Yellow. Let's see. Oh, got a green. Najayla, pick a color.
Blue.
Got a green. Roy Kia, pick one. What color?
Yellow.
Yellow. Let's see. You got it, girl. Good deal. So we got 5 winners or 6 winners so far. Tashandrick, I want you to try it.
Blue.
All right, he said blue. Got a green. And then we got Zayden. Zayden, what do you think? Zayden fell asleep. Miranda, go for Zayden. What do you think?
I'm not asleep.
Oh, you better hurry.
What you asked?
What color am I going to pick? Green, yellow, or blue?
I think blue.
All right, let's see. He got it. We got another winner. All right, Joel, are you back?
I'm here.
All right, pick a color, man. Am I going to pick yellow, blue, or green?
Green.
All right, he said green. Uh-oh. We got a yellow. Good try. Let's see. Is there anybody else that has not gone? I think it was Chris. Chris, can you pick a color? What number are we at, Haley?
If he goes, it's 15.
All right, why don't you go for him? What color?
Yellow.
Yellow again? All right, we got a blue. Emma, see if you can redeem yourself. What color do you want to go with?
Blue.
All right, she said blue. Oh. Who else didn't get it a while ago? Was it Isabella?
No, I got it right.
Oh, she got it right. Eli didn't get it right, I don't think. Eli, you got.
I got blue.
All right, pick one, Eli.
I already got it right.
Well, do it again. See if you got 100% chance.
Green.
All right, he said green. Oh, you can't tell your mom you want to play the lottery tonight. All right, Jemiah, pick one.
Blue. Probably like blue.
All right, she's 2 for 2. And wasn't that 17?
Mr. Martin, did I get mine right?
No, come on, do it again. Pick one.
I picked green this time.
Look at you go.
I got it right.
You got it right. That's green. Are we at 20 yet?
I believe we're on 19.
All right, 19. Deonte, pick one. What color?
Green.
Green, she said. I'm gonna mix this up real good. Look at it. Good job. Got a winner. And let's see if Lainey can do it once. She made it back. Lainey, pick a color.
Yellow.
She said yellow. I haven't been real lucky on yellow. Got a green. All right, so that should be all 20. So with these 20 trials, what color got picked most often?
Blue. Green.
I thought green got picked more. Did y'all write it down?
I think green got it more.
What'd you say, Haley?
Green got picked more.
How many times did it get picked?
8.
All right, and then how many times did blue get picked?
6.
And then how many times did yellow get picked? All right. So out of those results, what color do you think there's more of?
Green. Green.
Which color out of those three do you think has the least amount of blocks?
Yellow.
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 Y'all are right. Y'all are right. See how doing a good amount of trials can help you be able to predict how much is in something, even without counting it? It's pretty neat, huh? So that's how probability works. So that's why I like it. All right. So if you would, Roy Kia, read what we got down here in this dark gray.
Analyzing the contents of the container will help you figure out the possible outcomes and the theoretical probability. If you choose from a container with blue marbles, 6 green marbles, and 2 yellow marbles, what are the possible outcomes?
All right. So let's go ahead and see what we get. Wow. All right. So she's got 1, 2, 3, 4 blues, 2 yellows, and how many greens?
6.
Good. So when we put our sample space in there, what exactly are we doing?
Alphabetical order.
Well, they did put it in alphabetical order, but it's also showing how many times you could possibly land on blue, how many times you could possibly land on green, and how many times you could possibly land on yellow. So that is our sample space. So read that down there for us, Najela.
There are 12 marbles, 4 blue, 6 green, and 2 yellow. Go to the next panel to explore the theoretical probability of getting each color.
All right, so I want y'all to think about that. How would you determine the theoretical probability of getting a blue? What do you think, Sarah?
What was the question?
How would you determine the theoretical probability for picking a blue marble? Remember, there's 12 marbles in all. So, what is the chance that you would pick a blue marble out of those 12 marbles? Can anybody help Sarah?
There's a 4 out of 12 chance that you would get a blue.
All right. Why is it 4 out of 12?
Because there's 4 picked, and there's 12 marbles that were picked in total.
All right. And that's what you said also, Roy Kia?
Yes, sir.
All right. So, Sarah, does that make sense?
Yes, sir.
All right. So, I want you to try the next one. What is the probability that you'll pick a green marble? What's the theoretical probability of picking a green marble?
There's 6 green marbles.
Correct. So what would that theoretical probability be? Of what out of what chance? They said that the chance we'd pick a blue marble would be a 4 out of 12 chance. So what would the chance that we would get a green marble be?
6 over 12.
Great job. Great job.
Yes.
All right. So, Eli, what would be the theoretical probability that we would get a yellow marble?
2 over 12.
All right. And why? is that?
Because there were 2 yellow marbles.
Correct. All right, so let's check our work and see if we got it. Now they went ahead and divided and got the decimal value of that. Could we have done that as well? Yeah, definitely. All right, so does this theoretical probability compare to the experimental probability that we did just a second ago?
Yes.
It was pretty close, wasn't it? What did we get again, Haley?
We got 6 blue, and I didn't see it 2 of the green, so we got 10 green and then 4 yellow.
All right, so we got 6 out of 20. We had 10 out of 20. And then we had 4 yellow.
Yes, sir.
All right, so we're going to do a little bit of math and see how close we are. Because this is actually the same amount of cubes that I had in the bag. So what would I do to get my experimental probability?
6 divided by 20.
Good job, girls. Hey, that's like exactly the same, ain't it? Or it's really close. That's actually 0.3, and it just keeps going. But that's pretty close. All right, what do we get for 10/20ths? Is that the same?
Yes, sir. Yes, sir.
And so if those are the same, what's that mean about this? You think it's going to be the same?
Yes.
It's pretty close. Because that's only 0.04 difference, right? Or 400ths. So that's pretty close, right? So do you think that our experimental probability is fairly close to our theoretical probability?
Yes. Yes, sir.
Yes, definitely. Is that pretty neat to y'all?
Yes.
I mean, it's usable. Let me put it that way. It's something that you could use. All right, let's take a look at page 7. Tashandra, go ahead and read this for us.
Consider the outcomes of randomly selecting a marble from the container. You can say that the outcome of selecting either a blue, green, or yellow marble is certain. The, the outcome is certain because it will happen with 100% certainty. The probability of selecting either a blue, green, or yellow marble is 12 out of 12 or 12 over 12, which equals 1. If you add the probabilities for each cover, the sum is also 1. What's the probability of selecting a red marble from the container? Since the container does not have any red marbles, it is impossible to select one. An event that cannot happen is called an impossible event. The probability of an impossible event is 0. Using probability notation, you can write P parentheses red equals 0.
All right, so what's an impossible event?
An event that cannot happen.
Correct, an event that cannot happen. What is a certain event? What is a certain event?
It will happen with 100% certainty.
Correct. So no matter what, it's going to happen. So like if you had 10 red marbles and I said, what is the chance that you'll pick a red marble out of that bag? What is it going to be?
10 over 10.
Yeah, it'd be 10 out of 10, which is 1, which we know as what? Certain. Perfect. Does anybody got a question about that?
No, sir.
All right. All right. If you would you read this for us, Roykia?
Consider a jar with only green and blue marbles. The event of selecting a green marble and the event of selecting a blue marble are complementary
Good job.
events. The complement of any event, such as selecting a blue marble, is the event of selecting any marble other than a blue marble. The sum of the probabilities of an event and its complement 100, 1 or 100%, since you can only select a blue marble or not blue marble in symbols that equation, and for the jar find P.
All right. So since we can only select blue marbles or not a blue marble, we got the probability of picking a blue plus the probability of getting a not blue is 1. So it's for certain, right? So it says for the jar shown, find the P that is, or the probability that is not blue. All right. So with that being said, we can see this jar, right? Yes or no? Right there, that jar. Do y'all see that?
Yes.
So how many marbles do we have?
8.
We got 8 marbles.
8.
Okay. So remember, 8 is the total amount of what? Wouldn't that be the total what?
Marbles.
Total marbles or total outcomes? All right. So we know that the chance that we'll get a blue is how many?
5.
Good.
5.
Now, if we know that 5/8 plus the not blue equals 1, what could we do to find out what is the not blue? What could you do to get your answer?
Count the green.
You could, that's one way. You could count the green, or you could do 1 minus 5/8, right? Because we know that 1 is the same thing as saying 8/8. And so if you do 8/8 minus 5/8, it's going to get you the same answer that Roy Kia told us. So if you count those greens, how many are there?
3.
Good, 3/8. So using this information, it says let's check that real quick and see if that's how they did it. Does that look any different than what we just did?
No, sir.
No, it looks exactly the same, right? So it says, read this down here for us, please, Layla.
In the example above, there were only 2 outcomes, drawing a green or a blue marble. What if there were two yellow marbles added to your jar above? The complement of selecting a blue would be not selecting a blue, which is equivalent to the probability of selecting a green, plus the probability of selecting a yellow.
All right. So, what do y'all think? What do y'all think about that? Read what she put right here. So it says, in the example above, there were only two outcomes. You could draw a green or a blue marble. Well, what if you added two yellow marbles? What's it say about the complement? So, in other words, the complement of selecting a blue would be what? What are the only other two possible outcomes that you could get?
5 out of 10.
Well, so correct. The chance that you would get a blue would be 5 out of 10. So my question to you is the complement of selecting a blue, meaning the only other possible outcomes would be what colors?
Yellow and green.
Yellow and green, which would also be whoever just answered that. They said what? Say that again, my person that said 5 out of 10.
Say 5 out of 10 again?
Yeah, who said that?
Me.
Okay, well, that's right, because there's a 5 out of 10 chance you're going to get a green and yellow marble when you draw, and there's a 5 out of 10 chance that you'll get a blue marble. So you're 100% correct. And so if you have not answered question 2 in your workbook, I believe that's where we're at. All right, so take a look at this. Kaylee, go ahead and read this for us.
Now test your understanding of theoretical probability. Think about the possible outcomes for spinning the spinner, tossing the number cube, flipping the coin, and selecting marbles. Can you drag the tiles to express each theoretical probability as a ratio?
All right. So what do you think we could do here?
Count the different parts of it and then put what it's out of overall.
Okay, so it says the probability of selecting a 5 is what?
2 out of 5.
Perfect job, because there's 5 what?
There's 5 sections on the wheel.
Unit things.
Y'all got it going on. All right, so Isabella, how would you determine the probability that you will not select a 5?
Wait, what? Because so. Wait, what'd you ask?
How would you determine the probability that you will not select a 5?
Because it's not.
Correct. So how many are not 5?
3.
Do y'all agree with that?
Yes, sir.
Oh, that is right. Good deal. Joel, the probability that you will get an 8 on a die that is 1 through 6. I don't know if he's there. Somebody help him out. Go ahead, Roykia.
0.
I'm here.
All right. So Roykia said 0. Do you agree with that, Joel?
Yes.
All right. Look at this next one. We got the probability that we'll select an A. What do you think, Zayden? What's the probability that you'll select an A out of this jar right here? Zayden's playing Fortnite. Somebody help him out.
5 out of 7.
5.
All right, so it's 5 out of how many?
8.
7.
7 of them. Yeah, we got 7 of them. All right, so what's the probability that you will not get a green one?
5 out of 7.
How'd you get that answer?
Because there are 5 that aren't green.
Great job. All right, and this last one, what is the probability that you will land on tails if you flip that coin? What do you think, Layla?
It'll be 1.
All right, does everybody agree?
Yes, sir.
Yes.
All right, let's check it. Look at us. All we do is get them right. All right, so if you have not answered questions 1, 2, and 3 yet in your workbook, it is definitely time to get those done. And I'm going to click on page 10. All right, if you would you read this for us, please, Miss Destiny?
This jar contains 5 blue marbles and 3 green marbles. Vanessa wants to.
You're doing good. Keep going.
Okay. This jar contains 5 blue marbles and 3 green marbles. Vanessa wants the probability of selecting 3 yellow marbles from this jar to be approximately 1 over 3. How many yellow marbles should she add to the jar? Make a prediction and then play the animation to explore the probabilities.
All right. So it says drag those yellow marbles into that jar. When you think we have the right number of yellow marbles, click to calculate the probability of selecting a color. As we add yellow marbles, how are the probabilities affected? So what's going to happen when I put 1 in here? What would happen? What's going to be the probability of getting a blue?
5 out of 8.
Correct. Wait, not 5 out of 8, 5 out of 9, because there's now 9 because we added that 1 yellow. All right. What about our green?
3 out of 9. 3.
And what would our yellow be?
1 out of 9.
Good. All right. So what if we were to put 2 more marbles in there? What if we put 2 yellow marbles instead of 1?
You'd have 10.
Correct. So our new ones would be what?
5 out of 10, 3 out of 10, and 2 out of 10.
Perfect job. Does anybody have a question about why it's changing? Or does everybody feel pretty confident in what's happening here? All right. So what if we had a spinner that had 3 equal parts? So say it had blue, green, and yellow, and they all had an equal chance of landing on it. What is a certain probability that could happen on that spinner? What is something for certain?
That it will land on A, B, or C.
Correct. It's either going to land on blue, green, or yellow. That's 100% certain. Well, what's something that is impossible?
To not land on one.
Yeah, not landing on one of those. It has to land on one. That is correct. All right. So what would be an unlikely probability? Like if you did like a trial of 10, what's something that would be unlikely?
To have the rest of any other ones, but don't have one certain.
I got you. Like, so in other words, it'd be very tough to land on one of the same colors 10 times in a row. Is that what you're saying?
Like at all.
Okay. Okay. All right. So we were supposed to answer questions 5, 6, and 7. So if you did not answer questions 5, 6, and 7, I definitely want you to try to do those. I only want you to spend about 15 minutes on that tonight for homework. I don't want you spending over 15 minutes. So after you've worked for 15 minutes, that's it. So do what you can do. What you can't do, put a question mark by it and ask me tomorrow in class about it, and we'll do it. Now we're at the conclusion of our lesson for topic 9, block